Now, there are moles on the periodic table. That's why the periodic table is our centerpiece for this course, and that's why we're talking about moles. So we see a couple of different numbers in each box of the element on the periodic table. So for example, you look at oxygen, second row, 8 and 15.999 of the numbers that appear. One of them represents a mole, specifically a mole of oxygen atoms. Okay, which number is that? Well, we discussed the smaller number last week. The smaller number, the 8 up there, is what? What is it called? Atomic number. An atomic number represents the number of protons, the positive charges in the nucleus. Okay? But the entire mass is represented by the 15.999, which is typically rounded to 16. And so we say the atomic mass of oxygen is 16. That's the way you'll typically see it represented in most books. And what that means is that if you had 6.02 times 10 to the 23 atoms of oxygen, they would have a mass of 15.999 grams. Likewise, if you had a mole of hydrogen, that's the first element on the periodic table, atomic number 1, those atoms would have a mass of 1.008. So those atomic weights on the periodic table are really the mass of a mole of the atoms. And they are comparative weights. So when you quickly look at hydrogen versus oxygen, hydrogen being atomic weight, mass of 1, oxygen of 16, it means oxygen atoms have 16 times the mass of hydrogen atoms. So a mole is 6.02 times 10 to the 23 of any items. It is the atomic mass represented in grams. It is also when you have atoms combining to make molecules. Those are the formula weight. You simply add up the mass of the individual atoms to find the mass of a mole. So a mole of water, for example, if you round out those numbers, would have a mass of how many grams? 16, right. 1 plus 16. I'm rounding them out, okay? Yeah. But not 1 plus 16, because that's 17. You've got 2 hydrogens, okay, bonded to 1 oxygen. So it's 2 times 1 plus 16 or 18.